All right. Now, not always will you have to use the Pythagorean theorem because there are actually some special right triangles. And there's two types of right triangles. And it all depends if they tell you, obviously, if it's a right triangle, it's going to have, a right angle. And it's going to have one angle that is 90 degrees. You can see where I'm drawing the black square around 90 degrees. But if you see one of your other angles in a right triangle is 30 or 60, well, then that means that is a 30, 60, 90 right triangle. It's a special right triangle, and we'll talk about that here in just a second. The other type of special right triangle is the 45, 45, 90, which is this triangle right here. Well, let's notice the other two angles of the triangle are both 45. They're two congruent angles in this right triangle. Well, what do we know about triangles if they have two congruent angles? What do we know about the sides? That's right. If there's two congruent angles, then that means there's two congruent sides, right? My S did not turn out so well. There, I'll fix it. Okay. So there's a little statement that says, why are they special? Well, in a special right triangle, whether it's a 30, 60, 90 or a 45, 45, 90, there's a special, what I call a special relationship with the legs and the hypotenuse. And you'll see what I mean here in just a second. Okay? So let me move down here to this first theorem. First, we're just going to deal with the 45, 45. Okay. Now again, remember this side right here and that side right there, those are legs. And since it's a 45, 45, that means the legs are congruent. This leg is congruent to that leg. They're equal. So let's just say this leg here equal x. Well, doesn't this leg over down here have to equal x? Well, in a 45, 45, 90, the legs are congruent and the hypotenuse is whatever the legs are, which what do we say the legs are right now? What am I circling? That's right, we said the legs equal x. Well, the hypotenuse is whatever the legs equal, which is x, times the square root of 2. Well, there's a special ratio in a 45, 45, 90. Okay? Now, I like to set it up and teach it like this. Okay? So, each one of my angles represents the sides. For instance, the side or the leg opposite of 45 is one of the legs. Well, the other angle is 45, and so it's also the leg. And then the side that is opposite the right angle, or the 90-degree angle, is always the hypotenuse. Okay, well, we just used these x for the two legs, and then x times the square root of 2 for the hypotenuse. So let's plug stuff in. Well, this leg equals x. This other leg also equals x. And the hypotenuse is whatever the leg is, which is x, times the square root of 2. This is what I need you to remember how to use on a 30, 60, 90. And you'll see why as we go through. So let's do example A and B together. Okay? Well, let's look at part A, example A here. Okay? First of all, it's a 45, 45, 90, but notice they only gave me one angle, but since it's a right triangle, if I have a 90-degree angle and one of my angles is 45, well, that means this angle over here also has to be 45, which means that this leg is congruent to that leg. Well, if this is 8, what does this equal? This leg over here. That's right, it also equals 8. Well, this missing part, x, isn't that my hypotenuse? Well, let's think about the thing that I did, the ratio that I did. That whatever the leg is, or whatever the leg is, the hypotenuse, remember, is the leg times the square root of 2. For instance, if this is 8, that's also 8. And then the hypotenuse is whatever the leg is, which right now the leg is 8, times the square root of 2. Well, didn't we, using that ratio, didn't we just find our missing part? So the hypotenuse is that. Okay. Let's go to B right here. Well, now B, they don't tell us anything about the angles, do they? But notice what they tell us about these two sides. Well, since this is a right triangle with two equal sides, since they both equal x, then that means this is a 45, 45, 90. Well, remember a ratio, a leg and the other leg, because they're both the same, and the hypotenuse. Well, if a leg equals x, the other leg also equals x, and the hypotenuse is whatever the leg is, x times the square root of 2. Well, let's fill in what they gave us. Okay? Well, look what they gave us. I'm going to circle it in red. They gave us this part here is 5 radical 2. Well, isn't that the hypotenuse? It's opposite the right angle. So, I'm going to put 5 square root of 2 in for the hypotenuse. Well, isn't this 5 in the position where the x would be? So, what do each one of the legs equal? That's right. Each one of the legs are 5. Isn't that a lot easier than using the Pythagorean theorem? And so, that's what those two missing parts are. So we're on the next page here, and we have our other special right triangle. Alright, so a 30, 60, 90. Now, since, remember on the 45, 45, 90, we knew that we had two congruent legs. Well, we still have two legs in 36, 90, but they're not congruent. But what we do have, and for instance, this, excuse me, I forgot to put my pen back on. This is a leg, and this is my other leg. But the thing is one of them is shorter than the other. Well, how would I figure that out? Well, isn't this leg opposite that 30-degree angle? So that would make this the short leg. Okay? And that would make this the long leg. Okay? And then this side over here is always going to be my hypotenuse. Okay? Well, on a 30, 60, 90, there's a special relationship. Okay, so I'm going to kind of do the same thing that we did a while ago when I was teaching you the ratio. Okay, 30, 60, 90. Well, we'll just say SH for short. Okay, so that's the short leg. And then the leg that is opposite the 60-degree angle is the long leg. So long is for the long leg. And then the side opposite the hypotenuse is always the hypotenuse. Okay. So here's the ratio. We'll use blue now. So what I'm going to do is I'm going to tell you that the short leg equals x. I'm just giving it a variable. Well, from that, I can find the rest of it. The long leg is whatever the short leg is, x times the square root of 3. And then the hypotenuse is the short leg, which is x times 2, or 2x. It's double. The hypotenuse is twice the size. So, I don't like this first example that they give you here. We're going to do this example to the right that has this length on it that's 9, but I want to give you an easier problem first. So, I'm going to draw another 30, 60, 90. And there's my 30-degree angle, and so if that's 30, that's 60. Okay, and I'm going to go ahead and give this measure right here. I'm going to tell you that this side is 4. And we're going to find that missing part and that missing part. So I've given them x and y. Well, let's kind of remember the ratio. What as I gave you? 30, 60, 90. Okay, and that has to do with the short. That has to do with the long. Remember, SH is for short, and then the hypotenuse always relates to the 90-degree angle. Well, right now I've given you what the short leg is. The short leg is 4. Okay. Well, let's look up here when I'm drawing my arrow that I'm doing in black up here. Everybody see it? Now I'm circling that arrow. Remember the relationship. If the short leg equals x, then the long leg is the short leg x times the radical 3. Well, down here, we already have the short leg equaling 4. Okay, so that's our x. X equals 4. So isn't our long leg the short leg, which is 4 times the square root of 3? Right? And our hypotenuse, again, go back up here to my arrow and this thing. Look what I did to find the hypotenuse. I took whatever the short leg was, x, and multiplied it by 2. So it's double. Well, here the x is 4, so I just need to go 2 times 4, which is 8, and so the hypotenuse would be 8. And I found my 2 missing parts. This is 4 radical 3, as that's the long leg, and this equals 8, because the hypotenuse is double that. Well, so now let's do this problem over here that's at the right, and I'll go in red. Well, they give me this measure right here that is 9. Well, what leg is this? Well, it's opposite the 60, so isn't this my long leg? My x is my short leg, and my y is my hypotenuse. So let's go ahead and put in what we know. We got short, long, and hypotenuse. Okay? Well, we don't know the short, it's x. We do know the long, it's my 9. And the hypotenuse, we don't know what it is. They've got y right now, but we got to remember with the ratio, I'm circling again, that whatever our short leg is, remember it doubles, right? It's twice short leg, so I'm not going to put y. I'm going to go ahead and put 2x, okay? 2 times x. Well, now, when we did this, didn't the long leg have to be, if you remember, it was whatever the short leg is times the square root of 3. Well, right now, don't these two things equal each other? Right? 9 equals, or x radical 3 equals 9. Well, x radical 3 equals 9. So I need to solve for x. Well, what is being done to x? What is this square root of 3 doing to x? It's multiplying it. The square root of 3 is just a number. So a number next to x means multiply. Well, how do we undo multiply? Well, we divide. So we would divide by the square root of 3. Okay. And so that cancels that out, and this leaves me x. Now I've got to kind of move up a little bit. I'm sorry. Okay. So now what I have is 9 square root of 3. Well, when we did radicals last week, can we leave a radical in the denominator? No, we can't. So the way we get rid of that is we take and we multiply by that denominator, the square root of 3 over the square root of 3. Now, when we multiply straight across, well, the square root of 3 times the square root of 3 is just 3. So I have just 3 on bottom, and then 9 times the square root of 3 is 9 times the square root of 3. Now, pretend for just a second that this square root of 3 that I'm circling in red doesn't exist. Well, what is 9 divided by 3? 9 divided by 3 is 3. So those would factor out, and I'd be left with 3. And then I still have the radical 3. So I would have that x equals, I'm going blue, x equals 3 radical 3. So now I know the short leg. It's 3 radical 3. We already know that the long leg is 9. And isn't the hypotenuse double this short leg? Well, when I double or multiply by 2, I'm only going to multiply that number that's on the outside. So what is 2 times 3? That's right, it's 6. And so I would have 6 radical 3. And so that's the missing part. Well, we're going to do some more. Now, what I'm going to have you guys do is I want you guys to do number 1 and number 4 on your own. Okay? Now, I am going to give you a hint. They want you to find this h right here in this problem. Well, look what I'm highlighting right here. Don't I have a right triangle? Now, I don't know any angle measures right now, right? But I do. There are some things that I know. First of all, I know 2 sides, so I could use Pythagorean theorem. Or since this side is 4, that side is 4, isn't this side, this whole thing also 4? So I have 3 congruent sides, so doesn't that mean each one of my angles before I had this thing that cut it in half, aren't they all 60 degrees? 60 degrees, 60 degrees, 60 degrees. Well, so this angle right here that I'm going to use red, this angle right there, isn't that 60 degrees? Well, isn't this right triangle a 30, 60, 90? Okay. Well, so that would make this be my long leg, and so you would use your ratio. But you guys do 1 and 4. See if you can do it. And then, actually, I tell you what, you hold off on 1 and 4. I'll do 2 and 3, and then when I'm finished with 2 and 3, you guys will do 1 and 4. Kind of got to slide this over so I got some more room because I already know I'm going to get cramped for space a little bit. Okay. First of all, I need to figure out what type of right triangle is number 2. Well, since this leg and this leg are congruent, doesn't that mean that it's a 45-45, right? Because the two legs are congruent. Well, let's remember our ratio on a 45-45. I'm going to go ahead and write the angle measures. And then that's one of my legs. And that's my other leg. And then what was the special thing about the hypotenuse? Wasn't the hypotenuse whatever the leg was times the square root of 2? So I already have the square root of 2 times the square root of 2, right? And so that's what we're trying to find. That's the thing that we're trying to find is the hypotenuse, which is going to be the square root of 2 times the square root of 2, which when I multiply two square roots, I can multiply them together, so that would give me the square root of 4. And what is the square root of 4? Isn't that a perfect square number? It sure is. And so it is 2. So my missing part is 2. Okay? Alright. I'm going to slide over and do number 3. Now number 3 is a right triangle, but it's my other type. It's my 30, 60, 90. Well, they give me this leg right here. Well, what leg is that? Well, it's opposite 30-degree angle, so that means this is the short, or the SH. This missing part, that is my long. They didn't ask me to find the hypotenuse. Alright, well remember the ratio. SH, long, and the hypotenuse. Well, if you know what the short leg is radical 3, or square root of 3. Your long leg, remember, was whatever the short leg was, which in this case is the square root of 3, times the square root of 3. And we don't have to worry about the hypotenuse, but if we did, we would double the short leg. But anyway, so this thing that I've just done, that is what I'm trying to do. Well, the square root of 3 times the square root of 3, well, isn't that 9? And the square root of 9 is 3. And so my long leg is 3. Alright, so now you have finished the notes on both lessons on the Pythagorean theorem and the two types of special right triangles. What I want you to do on the Pythagorean theorem on 9.1, I want you to do all the problems on those except the last two problems. I don't on 9.1. I don't want you to do number 16 and 17. And then the assignment that is attached to the special right triangles, there's actually 2 pages of homework problems, but I only want you to do 1 through 10. I don't want you to do the second page. Okay? So I did cut down the assignment just a little bit, and all this is due. You need to turn in your notes, and you need to turn in both assignments the next class period, and the sub will get them to me so that I can grade them and get some grades in the book for you. Okay? So if you can't remember the directions, you have this video because I've told you what you need to do. Okay? All right.